In this video, I'm going to do some questions from the chapter areas related to circle. And the first one is example 2 from textbook. It says find the area of this segment AYB. So this is what segment AYB, whose area we have to calculate. If its radius is 21 centimeter, yes, and the central angle is 120 degree. Now, what we know from the formula that area of this segment is equal to area of this sector minus area of the triangle. That means from this sector, if we subtract the area of this triangle, right? Area of this triangle, if I remove this, we are going to get the area of this segment. So that is what we are going to do. So first I'm going to find the area of this sector, and you must be knowing its formula is theta over 360 into pi r square. Now how much is theta? Theta is 120 degree and radius is 21. So let's plug in the values here. So this is area of this sector. I can write here is equal to theta. So the equal to sign. Okay, fine. Theta is 120 degree over 360 into pi. Pi is what? Not mentioned. So 22 upon 7. Radius is 21. So 21 into 21. Now this get cancelled. 7 1 times, 7 3 times. We have 12 3 times. 0 0 get cancelled. 3 further get cancelled. So what I'm getting 21 into 22 into 21, right? So it's going to be 462 centimeter square. Now this gives you the area of the sector. Now we are going to find the area of the triangle. Now for finding the area of the triangle, let me, to make it clear, I'm taking out this triangle from here. As you can see, I'll take out this triangle from here. We'll do it. We're working over here. Now I'll name as it is named over here. This is A, this is B, this is the center O, the radii being 21, and the central angle, which is AOB as 120. So, you can see that this is neither an equilateral triangle nor a right angle triangles. So we are going to use the formula half base into height to find its area, but then we don't know the base or height. That's why I'm using a construction. So what I did here, have drawn a perpendicular from O to the AB. And what you know, that perpendicular drawn from the center bisects the chord. That means AM is equal to BM. Well, over here I'm writing AM is equal to BM. In your exam, you should write down the reason as well. Right. And the same way from the property, I can say that this angle will be 60 degree. You may say using congruency. Now, what next I'm going to do is to use trigonometric ratio in any of these triangle. Let's say I'm taking this one, any of these right angle triangle. So I'll be applying sine here, sine 60. This is 0. Sine 60 is equal to perpendicular. The side opposite to this angle is perpendicular. So the perpendicular is what? AM. So it's perpendicular over hypotenuse. Hypotenuse is AO. Sine 60 is how much? Root 3 by 2. And AM is AM. AO is 21. So by cross multiplication, I can say the length of AM is going to be 21 root 3 by 2. Now further you can see that AM and BM are equal here. That means from here what you can see that AB will be AB. This is AB, right? It should be twice of AM, and twice of this is what? 21 root 3 centimeter. Yeah, we got this. Now next I'm going to apply cos, and cos, let me accommodate here. Should I place a line? And I'm getting cos here, and cos 60 is what? Base upon hypotenuse. From figure you can say base is OM and hypotenuse is AM. Cos 60 is half. OA missing. AM 21. So by cross multiplication, we got OM is equal to 21 over 2 centimeter. Okay. So we got the base and the height. And so now we can calculate the area of the triangle, and the triangle AOB and its area is half into base. The base is AB, which is base is AB, which is 21 over root 3, and altitude is 21 over 2. So if we got the area, 21 into 21 is 441 root 3, and 2 into 2 is 4 centimeter square. Check here, we got what are the things we got? We got the area of the sector as this and the area of the triangle as this. So if you subtract these two, you should get the area of the segment. So I'll write the area of this segment over here. So the area of the segment is equal to area of the sector, which is 462, minus area of the triangle, which is 441 over root 3 by 4. And you put a bracket and write centimeter square. As this, the value of root 3 is not given, I suggest you can leave the answer here only. No marks would be deducted for that. So this is the question. So one more reviews here. We had to find the area of the segment, and area of the segment is area of the sector minus area of the triangle. Applying this formula of area of sector, I calculated the area of the sector. We had the theta, we had radius, so we plug in the value. We got the area of the sector as 462 centimeters square, right? And in order to find the area of this triangle here, we first drawn a perpendicular, applied trigonometric ratio to get the length of AM and that of AO, and AB being twice of AM. We got the base and height. Once we get the base and height, we calculated the area of this triangle. We got this. And finally, we subtracted them to get the area of this required segment. Well, the segment is must be very clear to you now that we are talking about this segment. In the next question, we have to find the area of a sector of radius 6 centimeter angle of this sector is 60 degrees. So it's a very easy question here. Let me first draw the sector over here. I draw a circle first, and taking the center as, say, this one, I'll draw another line. All right. One line seems to be bigger, but it's okay. So this is what I name it as OAB, and the central, this angle, that is area of the angle of the sector is given. All you have to do is to find the area of this sector. So we know that's a minor sector. And we have a formula here. Area of a sector is what? Theta over 360. Theta is 60 over 360. That multiplied by pi, not mentioned. So 22 over 7 into r square. R is 6. So 6 into 6. But I can see that these can be reduced. 0, 0 get cancelled. So 6, 6 are 36. That's right. Yeah, 6, 6 are 36. I can further cancel these 6. So it's 6 into 2, that is 12. 132 over 7 centimeter square is the answer. The next question is find the area of the quadrant, a quadrant of a circle whose circumference is this. So what is a quadrant? A quadrant is what? A sector whose quadrant is a sector. Let me raise this a big one. Right. So quadrant is a sector whose central angle, so this is the center. So I make a quadrant. And as I said, a quadrant is a sector, right, whose central angle is 90 degree. And area of this quadrant is what? It's 1/4 the area of a circle. So we have to find the area of this region, right? We have to get the area of this region. And the formula for finding the area of a quadrant is what? This is 1/4 the area of a circle. So area of circle is pi r squared. So we can use this formula as 1/4 the pi r square. Well, clearly we have to get the radius. Once we get the radius, we can find out. So we have the circumference. And what is the formula for circumference of a circle? It is 2 pi r. So I can say the circumference, let's say I use the letter C for the circumference, whose formula is 2 pi r, replacing C with the value given here as 22 is equal to 2 into pi's 22 over 7. The radius here is missing, so I'll write r only into r. So here 22, 22 get cancelled. On transposing these numbers, it is 7 over 2 centimeter. Now next is what? Simply plug in the value of the radius pi as 22 upon 7 and the radius as 7 over 2. So it's r squared, 7 over 2 into 7 over 2. Some calculation is 7 and 7 get cancelled. 2 with this as 11. So what we are getting 77 in the numerator, 2 and 4 into 2 is 8. So this much centimeter square is the area of the quadrant. Quadrant. That will be the answer for this. In the next question, it says the minute hand of a clock is 14 centimeter. We have to find the area swept by the minute hand in 5 minutes. So let's say if I make a clock here and let's say I choose this with the center and I'll take a minute hand. This minute hand, right? As you know that in one complete revolution, it makes an angle of 360 degree. That means it takes 60 minutes to make 360 degree and we need how much? 5 minutes. That means 5 minutes will be what? From here to say here, right? And we have to find the area swept by this with it in this 5 minutes. That means we have to calculate what? This area. We have to calculate this area, which is clearly a sector. So we'll actually be finding the area of this sector. Now, what should be the angle here? Let's once again decide. We know that in 60 minutes, it makes 360 degree. That means in 1 minute, it should make how much? 360 over 60. That is 6 degree. And how much minute is there? 5 minutes. So clearly, in 5 minutes, 5 minutes, in 5 minutes. In 5 minutes, the angle made will be what? 6 into 5. That is 30 degree. Yeah. So once we got this angle, we are going to apply this formula finding the area of a sector, that is theta over 360 degrees. So theta is 30 degree and the radius will be what? The radius will be this, that is 14 centimeter. The length of the minute hand will be its radius. So simply we are going to find the area by replacing theta with 30 over 360 into pi 22 over 7 and r being 14. So it's 14 into 14. Right. I can see that the zeros get cancelled. 3 1 times, 3 12 times, 7 1 times, 7 2 times, and then what? 2 1 times, 2 6 times, 6 2 3 times, and 2 11 times. So 11 into 14 is what? 154 over 3 centimeter square, right? It should be centimeter square. So this much area is swept by the minute hand in 5 minutes. In the next question, it says a chord of a circle of radius 10 centimeter subtends a right angle at the center. We have to find the area of the corresponding minor segment and major sector. So let's say if I first draw a circle, and this is what a circle I've drawn, and then I'm taking this as the center and making an angle of 90 degree. at the center. Let's say I name it as OAB and join this so as to get the area. The first part I'm doing is the area of the segment, and this is what the segment here. Now see what else we know here. We know the radius given as 10 centimeter. This is 10 only. So what we know, in order to find the area of a segment, it is area of a sector minus area of the triangle. So the first part, to get the area of the sector, and area of a sector formula is theta over 360 into pi r square, and theta being 90 degree. So I can say this is area of the sector is what? Theta, which is 90 over 360 into pi, which is 3.14 as per the question, and r square is 10 into 10. This is divisible by 4 times, so you are getting 1 over 4, and this multiplied by 100 will be 314. I can reduce it 157 and by 2 times. So we got this as 157 over 2 centimeter square. So we got the area of the minor segment, right? So minor segment is what we are getting. So area of the minor segment comes out to be this. Now the next thing is what? To get the big area of the triangle, right? And as you can see, this is a right angle triangle. So we'll be applying half base into height to get the area of this triangle. So I'll keep this aside. And then to calculate the area of the triangle. Okay, so area of triangle is what? Half base into height, half into base into height. As you can see, this is 90 degrees. So this OA is its base and OB is its altitude. So these are radii only. That is 10 into 10. I can reduce it by 5 times and it will come as 5 into 10, 50 centimeters square. So now once we got the area of this, so I'm reducing it first, right? And this is going to be how much? 78.5. Now, as I said, in order to get the area of this segment, we have to get the area of sector, from which we'll subtract the area of the triangle. So let's say if I replace this over here only, so the required area will be how much? 78.5 minus 50. So that should give you how much? 28.5. Yeah, that's right. It should be 28.5 centimeters square. So we got the area of the segment. There is another part, and then what is it? We have to find the area of the measured sector. It's sector, right? The sector is going to be what? This is the sector. This is sector, right? This is a major sector here. And for that, we need the central angle. Since this is 90 degree and sum of all angle, this complete angle is 360. So if I talk about the reflex angle, right, we need a reflex angle AOB. Reflex angle AOB has to be what? 360 minus 90, that is equal to 270. So once we got the angle, we can easily find its area. So let's make some space for it. Now rest I'll do it here only. So we can say that the area of major sector, well, the formula remains same, whether it's a minor or major, it's going to be theta over 360 into pi r square. Theta, as we calculated, as 270 over 360 into pi, which is 3.14. Well, radius has to be same, that is r square, which is 10 into 10. This can be reduced. 0, 0 get cancelled. 9 3 times and 9 4 times. So it's going to be 3 over 4. And this when multiplied with 100 has to be 314. I can reduce it further. This is 2 1 times to 157 times. Now, once we did, what we have to do next is to multiply these numbers. So it cannot be reduced further. So we'll be multiplying 157 with 3. So 7 threes are 21, 7, and then 4. That divided by 2. So this will be half of this. In decimal, it should be 323. 235.5 centimeters square. So we got the area of this, and the area of this is area of this minor major sector as 235.5 centimeters square. That should be the answer for the question number 4. In this question number 5, it says in a circle of radius 21 centimeter, an arc subtend an angle of 60° at the center. So what I'm doing, I'm first, let's say if I draw a circle, so I've drawn a circle and I'm going to take its center as this and make an arc here so as to make an sector. Like this is what we are talking about, an arc here, right? This is the arc which is subtending an angle 60° at the center. Let's say if I take this as sector as OAB, so this angle is going to be 60° here. Now, once we got this information, let's do what is the first question they're asking for. As you can see, I've already written all the information regarding the formula. So in the first case, we have to find the length of the arc, which is theta over 360 into 2 pi r. So we have theta as 60°, so I can say 60 over 360 into 2 pi r. 2 pi is replaced with 22 upon 7, and the radius is how much? 21. So I can reduce it. This is divisible by 6. This can be reduced further by 3 times. And 3, 1, 7 threes are 21 and 21 get cancelled. So we get 22 centimeter. Yeah, it is centimeter. That's the final answer for this. Now, next is to get the area of this sector, and formula for the area of the sector is what? Let's say first, we have written the formula for the area of this sector. Area of a sector is theta over 360. So what is theta here? Theta is 60 over 360 into pi r square. Pi replaced with 22 upon 7. R is 21, so it's going to be 21 into 21. Here too I can see 7 1 times, 7 3 times get cancelled. This is divisible by 6 times. So now 3 1 time and 3 2 times, 2 1 times and 2 11 times. So now we get what? 21. So it's 1, 1 plus 2, 3, 231, right? So what I did, I multiplied 21 with 11. So we got 231, and this would be centimeters square. That's the area. Now in the later part, what you can see in the final part, we have to get the area of this segment. And for calculating the area of this segment, the formula is area of sector minus area of the triangle. Now for that, I'm joining this. We have already got the area of this sector. And as you can see from this area of this sector, if I subtract the area of this triangle, we can get the area of this segment. Now for finding the area of this segment, what is the triangle, right? As you can see, it's an equilateral triangle. Let me tell you that an isosceles triangle whose vertex angle is 60 degrees, an equilateral triangle. So area of triangle AOB, and since it is an equilateral triangle, it is root 3 by 4 into A square. So this is root 3 by 4, and what is A? A is 21, that is the side, 21 into 21. So now I'm going to just replace this value. This is going to be what? 441 times root 3 by 4. So as you can see from area of sector, that is this, for area of sector, which is 231 minus the area of this segment, sorry, area of the triangle. This is 4, right? So we can say this will be the area of this segment, area of the sector, which is this, minus area of the triangle, which is this. So we can say on subtracting area of the triangle from the area of the sector, we should get the area. And this is again in centimeter square. So this is the fifth question number. In question number 6, it says a chord of a circle whose radius is 15 centimeters subtends an angle of 60 degree at the center, and we have to find the area of the minor and the major segment, and the value of pi should be taken as 3.14. So what I'll do, let's say first I draw a circle here and a sector. Let's say I draw a sector. And the angle here at the center is how much? 60 degree. This is given as 60 degree. And I'll join this. Now, this is what the minor segment. That's the first part. Let's deal with the first part, then we'll discuss that. So we are going to get the minor segment first. So as you know that the area of a segment is area of the sector minus area of the triangle. So first thing that we will do is to find the area of this sector. An area of sector is what? Theta. As you can see, theta is how much? 60 degree. If I name this as OAB, so area of the minor segment here, first I'm getting the sector, minor sector, theta, which is 60 over 360 multiplied by pi, which is 20, is given 3.14, right? So pi r square, and r is how much? 15. So it's 15 multiplied by 15. So what is getting cancelled here? I can reduce this by 6 times, and 6, 3, 2 times, like 3, 2 times, and 3, 5 times. I can reduce this again with 157 or 1.57. So we got this as, this is in decimal calculation, right? All right. So we'll first multiply 15 with 5, and that is 75 multiplied by 1. We have to multiply 75 with 1.57. So it's come as 117.75 centimeters square. So this is what we got the area of the sector as of now. This is the area of the sector here. Next, as I said, once we got the area of the sector, we have to find the area of the triangle. What you can observe that this is an equilateral triangle. Why? Because this is, let me first write down, this is 15. You know that this is an isosceles triangle and whose vertex angle is 60. So an isosceles triangle whose vertex angle is 60 is an equilateral triangle. So I'll say area of triangle AOB is an equilateral triangle. So it's root 3 over 4 times A square. A is how much? 15. So it's 15 into 15. Value of root 3 is mentioned as 1.732. So I'll be taking this as 1.73. Only 1.73, not 2. And 15 into 15 is 225. Well, calculation is there and we have to do it. So now the other calculation involved again is 1.73 multiplied by 225. And whatever it comes would be divided by 4. So we are going to get 97 point is terminating 3125. So this is what we got. This time we got the area of this triangle, right? And area of triangle is this. Now, as I said, in order to get the area of this sector, right? So area of the minor sector. So we'll say that area of minor sector. As I said, the no segment, right? Sector we have already calculated. Area of the minor segment. Segment From the formula, as we have already discussed, area of this segment is area of the sector minus area of the triangle. So now we can say that the area of the segment, that is 117.75, I'll put additional zeros, minus 97.3125. So it will come as 20.4375. Right, we got this, and this is what? This is the area of this minor segment. Okay, so once we got this, now we have to find the area of the major segment. Now I should show you the major segment is what? This whole, right? Including this triangle. So we have two ways. Either you can add the area of the triangle on the major sector, or the alternately you can subtract the area. Let's first show you properly. Now from this whole circle, if we remove or trim this area, we are going to get the area of the major segment. So I think this will be shorter. That's what I'm going to do next. So I'll do it here. So this is area of major segment is will be what? Area of circle minus area of minor segment. So area of circle is what? Pi r square, and pi, which is 3.14 into r square, and radius is how much? 15 into 15. And the area of minor segment we have already calculated, and that comes out to be 20.437. Now if I multiply this, so 225, that's into, we'll have to multiply with 3.14. So it comes out to be 70 point, is it 70? It should be 70.6, 706 points. There's two place of decimal, 706.5 minus 20.4375. There's no way we can reduce the calculation as of now. So I'll be subtracting 20.4375 from it. So it'll give you 686.0625. And this is the area of what? This is the area. This is the area of this major segment. And this is how we will do this question. In this question, it says there is a chord of radius 12 centimeter that subtends an angle of 120 at the center, and we have to find the area of the corresponding segment, and we have to use pi as 3.14 and the value of root 3 as 1.73. Now, first of all, I'll make the diagram here. Like we are given a circle. Let's say I've taken the circle, and now I'm taking 2 points, say over here and over here. Let's this be the center. Center should be below. And now I'm joining this. And to obtain what? A triangle. So this is OAB. We have the radius given as 12. And this angle is given as 120. What we know that in order to get the area of segment, we need to area of sector, and from which we'll subtract the area of the triangle. That means in order to get the area of this region, that is area of this region, that is a segment. Area of segment is what? Area of the sector, this whole A from the area of this sector. We need to subtract the area of this triangle, right? So that is what I'm going to do here. Let's say, first of all, I'm going to find the area of this sector. So for calculating the area of sector, as we say, it is equal to theta, which is 120 over 360, that multiplied by pi. It's mentioned 3.14 value of pi, into r square, r being 12, so it's 12 into 12. Later I can reduce this 1 times and this being 3 times. With 3 I can further reduce it 3 1 times and 3 4 times. With further calculation I can see this is what? This is 3.14 into 12 into 4 is 48. So we have to multiply this 3.14 with 48. That comes out to be value for this, that is 48 multiplied by 1 13 point, right? 3.14 multiplied by 48 should give you 150. It's 150.72 centimeter square. Now, once we have obtained the area of this sector, the next thing that we will be doing is to find the area of this triangle. Now, what you can check here the triangle is not an equilateral triangle, nor it is a right angle triangle. So that means we first need to draw a triangle. Let's say, yeah, I made a triangle here. The same triangle I'm making it outside. So which is A, B, this being O, and this is 120 degree. So I'll first draw a perpendicular here. And what we know that a perpendicular drawn from the center bisects the chord, right? As you can see over here also, perpendicular drawn from the center bisects the chord. So I can say now, let's say, I can say that AM is equal to BM. Further, it also bisects the angle. Therefore, this angle will be 60 each. Now over here, I'm just considering one triangle. Let's say if I consider this triangle only, I'm going to use trigonometry. The thing is that since we do not know the base and the altitude, we are going to calculate the base first and the altitude to get the area of this triangle. So first, I can see this angle is 60, so this will be 30. Well, not needed. I can use trigonometric ratio directly. So first I'm going to apply sine 60 in this triangle is perpendicular. Clearly perpendicular is AM over hypotenuse, and hypotenuse as for the question is 12 in this case. Here the hypotenuse is the radius only, that is 12. Or you may write down the name first, that is OA. Sine 60 is what? Root 3 by 2, and AM is what we have to calculate, and OA, which is 12. Now check if I do cross multiplication here. If I do cross multiplication, what do we get here? This implies I can reduce it here only. So it comes out to be AM is equal to 6 times root 3. Now check, we have already discussed that here AM is equal to MB. So we can now straight away say that AB will be twice of AM. So that means the length of the base here AB is what? Twice of this will be 12 root 3 centimeter. Now we got the base here. In the next part, I'm going to find the altitude here. Now I should use this space to get the altitude. To get the altitude here, we'll be using cos here, and cos 60 is what? Base by hypotenuse. OM is the base and hypotenuse is AO. Cos 60 is half. And this is OM over AO is 12. Reducing it by 6 times, we got OM, which is the altitude, as 6 centimeter. So once we got the base as well as the altitude, now we can find the area of this triangle, applying half base into height. So for the area of this triangle, that is area triangle AOB is equal to half multiplied by base, which is AB as per the figure, and altitude is OM. So this is half. How much is AB? AB we calculated here, that is 12 root 3 multiplied by 6. That is the altitude. So I can reduce this. This is 2 1 times, 2 6 times. So 6 into 6, 36 root 3. And since we are given the value of root 3, we'll be replacing root 3 with 1.73. So the calculation will be 36 multiplied by 1.73. 0.73. It should give you how much? 62.28. Now check. We now know the area of the triangle, and we have also calculated the area of this sector. So let me once again show you that here the area of this sector is this, and the area of the triangle is this. Now what next? As I said, the formula here to calculate. If I make some space here directly to place it over here, not working. Let's erase it. This cannot be moved. It has moved. So now I'm going to place here only this value. It can come down. So area of the segment is what we have to calculate, which is area of this sector. Area of this sector we calculated as 150.72 minus area of the triangle, which we calculated as 62.28. And if I find its difference, it's 150.72, and from which we have to subtract 62.28, and that gives us 88.44. So that should be the required area of this segment, and the segment clearly is this. Right. In the next question, we are given a figure, and it says a horse is tied to a peg. Peg is the rope. Peg is the structure with which it is tied on one corner of a square field of side 15 meter. So we know this side as of this square as 15 meter. This is also 15 meter. By a means of rope, which is 5 meter long. That means the rope here, if I can show you the rope. So the rope is this, right? This is the rope with which it is tied. Now, what we have to find out is the area of the part it can graze, part of the field which can graze. Although it's a square field, and what we assume that the horse can actually using that rope. So with its rope, it can move. It can move a complete circle, right? Like this. But as you can see, only the grazing area has to be this only, because only this part. Okay, these region does not have a grasses, so we can say the area that it can graze is only this part. All right. So I'll show you the area it can graze will be this one. Only this part has grasses. So only these, uh, the whole field is has grass, but only these can be grazed, which is nothing. As I can see, it is equal to that of a sector. So we know that area of a sector, the formula is 1/4. That's 1/4 of a circle, pi r square. Now why sector? Because you know that each angle of a square is 90 degree. Here this angle is 90 degree, right? This angle is 90 degree. I'm talking about this angle, if you can see. So area of the sector is 1/4 pi r square. So it's 1/4 pi is how much? 3.14 multiplied. Radius is what? The length of the rope, which we discussed. So it's 5 into 5. So I can reduce this by 2 times. This will be 1.57. So other calculation involved is what? You have to multiply 25 with 1.57. Whatever it comes, that should be divided by 2. And we get this as 19.625 centimeter square. That's the first part, right? In the second part, what does it says? If what we have will be the increase in the grazing area if the rope were 10 meter longer instead of 5. So we have to find the increase area, not the new area. So assume the length of the rope is longer. So now what it can do, it can graze a longer area, like it can move up to a bigger sector, right? Let's say, so the color that I can use is, let's say now the next sector is this. So what you will do here, we have to find this area, the new area, right? The one which I'm shedding, this area is what? So we can say that from the area of the bigger sector, if you subtract the area of the smaller sector, we can get the area of the new area, or the increase in area, right? That's the increase in area. So what you'll do, let's say if I find the area of the new sector or quadrant, right? New sector, which is actually a quadrant in this case, is 1/4 the area of a circle. That is 1/4 pi r square. 1/4 pi is what? 3.14, and radius is 10. So it's 10 into 10. So this is how much it is? 100 multiplied is 314 divided by 4. So we can reduce it. 314 divided by 4 should give you 78.5. I'll put extra zeros. Now, since you know that we have to find the new area, the new area will be what? We have to find out only the new area. That means this area, right? So from the inner area, outer area, if you subtract the inner, we should get the answer. So we can say the required area. Let's say if I make some space. So the new grazing area for the second part, right? So the new required area, or yeah, will be the difference of this, that is 78.500 minus 19.625. So it's a 19.625. So if I subtract, we are going to get this as 58.875 centimeter square. So this should be the answer for the second part. This would be the answer for the second part here. In the next question, he says a brooch is made of silver in the form of a circle whose diameter is 35 mm, and the wire is also used in making 5 diameters, which is divided into 10 equal sectors. So there are 10 sectors. And for the first part, we have to find the length of the wire. So we can see where is this wire used. Number one, it is used in making the circumference, right? Circumference. And then it is also used in making 5 diameters. 1, 2, 3, 4, and 5 diameters. So clearly, we can say that the required length will be what? This is circumference, which is 2 pi r, and 2 pi r is same as pi d, right? I can write 5d, plus there are 5 diameters, so 5 into d, or 5d you can straight away write. It's 5 times d. Now we can plug in the value pi, which is 22/7, diameter 35, plus it is 5 times 35. I can reduce this. This is 1 time and this is 5 times. Yeah. So this is 110 and this is 35 into 5. So that is equal to 175. So it should give you 285, right? Yeah, 285 mm. No, 275. 100 added. This is something wrong I'm doing. This is what? 22 into 5 is 110. This is 110 plus, and this is coming as 175. Yes, so it's should be 285. Yeah, which I remember the answer. 285 mm. Okay, this is the first part, and we calculated the length of the wire required. In the later part, they're asking find the area of the each sector. Each sector, by that they mean to say one sector. So that means we'll be finding the area of this one sector. So for that, we need to find out the angle, that is the theta. So theta is what? As you can see, the complete angle is 360. And this is divided into how many sectors? There are 10 sectors. So 10 sectors are equal. So if I divide this, I'll get how much? 36 degree. Yeah, that's 36 degree. So once we get theta as 36 degree, for the second part, we can find the area of each sector. And what's the formula for sector? That is theta over 360 multiplied by pi r square. Let's plug in these values here. Theta is how much? It's 36 divided by 360 into pi, which is not mentioned. So I'll be taking 22 by 7 into r square. R is diameter is 35. So the radius will be what? 35 over 2, half of this. Calculation, this is divisible by this 10 times. 7 5 times 35. Then I can reduce this 5 2 times to 1 times to 11 times. So it's 385, right? 385 divided by 4. So that should be in millimeter square. Alternately, you could have also calculated the area directly, like as you know, there are 10 sectors and 10 are equal. So area of each sector will be what? 1/10 the area of a circle. So 1/10 the area of a circle is pi r square. This would also be equally correct. In the next question, it says to warn a ship for underwater rock, a lighthouse spread a light through red colored light over a sector of angle 80 degree and to a distance of 16.5 kilometer. We have to find the area of this sea which the ship are warned, and we have to take the pi as 3.14. So let's say if I say this is, I'm going to take a circle and then I'll join this center with this. So I'll join with the other side, right? Now you can see that the not swept here, area covered, right, is in the shape of a sector. And this is what the area covered. And we are given the radius, and the radius is how? It's in kilometer, 16.5 kilometer. This is the radius here. And the central angle here, the angle made given is 80 degree. What we have to calculate is very easily understood, that we'll be finding the area of this sector. And the area of a sector is what? Area of sector is equal to, this is theta over 360 multiplied by pi r square. Now we are going to just replace these values. How much is theta? Theta is clearly given as 80 over 360 multiplied by pi, which is mentioned 3.14. Now what about the radius? Should we keep in kilometer? Yeah, it should be a big calculation, but we'll keep it like that only. Not converting into meter. The zeros get cancelled here. With further calculation, I can see this can be reduced as 4 and this is 18. All right. Is it divisible? 6 plus, yeah, it's 6. It's divisible by 3. So I'm reducing it further. So if I remove this decimal here, make it 100. This is 5, 3 times 15 and 5, 3 times 15, 5, 20 times. This is 3, 6 times and 3, 11 times. This is 2, 2 times and 2, 10 times. All right. This is 3 and this is going to be how much? 1.57. This is 3, 1 times and 3, 3.3 times. In this question, it says a car has two wipers which do not overlap. Each wiper has a blade of 25 centimeters sweeping through an angle of 115 degree. We have to find the area cleaned in each sweep. Now let's say if I try making the wipers. Let's say this be the screen, and I mean to say that windscreen. And let's say this is the wiper here, and it is sweeping through an area, and the angle is what? Like, this is the first wiper, and clearly it is sweeping through an area of this much, which should be shape of a, this should be shape of a sector. This is the second wiper, and this is also sweeping an area like this. So what you can figure out that here this the area swept is in the shape of a sector. Yeah, this is the first wiper, and this will be the second wiper. It is sweeping these areas. Now we have the central angle given here. The angle so given is how much? This is 115 degree. This is also 115 degree. So what we are going to do is simply find the area of a sector, right? And we have a formula for finding the area of a sector. So the area of a sector is what? It is theta over 360 into pi r square. But since we have two such sectors, so the required area swept or area swept will be 2 multiplied by theta, 2 multiplied by this. Well, theta is how much? 115 degree. So 115 over 360 multiplied by pi, which is 22 upon 7. And the radius is 25 centimeters. So it's 25 square is 625. So it can be reduced. What I can see here, it is divisible by 5 and 5, 23 times, and 5, 72 times. Now rest, I think this can also be reduced by 36. Further, I can reduce this with 11 and this wing. This can be reduced by 11 and this is 18. So we have 23 into 11 into 625, that whole divided by 18 into 7 is how much? 126. It should be 126. Now we will finally multiply these numbers. So we'll multiply 23 with 11 and that multiplied by 625. So it should give you 158,125 centimeter square. So this is the final answer and this is the area swept by this. In this question, it says an umbrella has 8 ribs, right? These are the ribs here, which are equally spaced. Assuming that umbrella to be a flat circle of 45 centimeter, we have to find the area between the two consecutive ribs. So the area between two consecutive ribs is what? This is what the area we have to calculate. And if I look into this figure, this is the area. Clearly, this is a sector, and area of a sector is what? Theta over 360 into pi r square. That means we need the radius. The radius is given as 45 centimeter. And now we have to find out the angle here, the angle that is this theta. What you can do here is that to get the theta, you know that whole thing is 360. And since it is has 8 equal division, so 360 divided by 8 is what? 45. It should be 45. Theta is equal to 45 degree. Now radius, as you can see, it is given as how much? 45 centimeter, right? So what we did first, we actually found out the angle dividing 360 with 8 so as to get 45. Now next I'm going to place the values here. So the area of the sector theta, which is theta is which what we get as 45 degree, 45 over 360 multiplied by pi, not mentioned. So 22 upon 7 into r square. R is how much? 45 into 45. Now, what else calculation we have? We can reduce it by 8 times, and I can reduce this 11 and this becomes 4. So it's finally 11 into, and we have to get the square of 45. That's 45 into 45 is what? 2025 divided by 7 into 4, that is 28. So how much is, if I multiply by 11, this will get 22275 divided by 28 centimeter. Yeah, it's centimeter square should be the answer in this case. That is the area of one area of this sector. In this question, it says a round table cover has 6 equal design as shown in the figure. So these are the designs, right? These are the designs over here. And further, it says that the radius of this cover is 21 centimeters. So the radius of the cover will be this. This is the radius of the cover, and this is given as 28 centimeter. And what we have to find out here is find the cost of the making the design at the rate of rupees 0.35 centimeter square. Now the design, let's say if I talk about the design here, which is in the shape of a segment, as you can see in the figure, it's in the form of a segment, and this segment is what the design here, right? This segment is the design, and as you can see, there are 6 of them, right? There are 6 of them. So what we'll do, first we'll find the area of one segment. We'll find the area of one segment, and from which we'll multiply 6 to get the area of all the design. So what we will do here, as you can see this segment, let me color it once again, this segment. So to get the area of a segment, the formula is area of sector minus area of the triangle. So let's first find out the area of this sector, but formula for area of sector is what? Theta over 360 into pi r square. But we do not know the theta here, that is this angle. As you can see here, this is 360 degree and there are 6 equal designs. So each angle is equal. So I can say that the theta will be how much? 360 divided by, there are 6 equal parts. So that is equal to 60 degrees. So we'll say that theta is 60 degree. Now, once we have this theta, we can find the area, which is theta over 360. Theta is how much? 60 degree, right? So we can replace 60 over 360 into pi, which is 3.14 into r square, that is 28 into 28. Now next comes the area of a triangle here. The area of a triangle is what? This you can see it's an equilateral triangle, right? We have this equilateral triangle, and in case of an equilateral triangle, the area is what? Area of an equilateral triangle is root 3 over 4 a square. Well, a is what? You should know that why I'm taking this as an equilateral triangle, because this is an isosceles triangle with vertex angle as 60 degree. So that is always an equilateral triangle. So this is root 3 over 4 times a, and a is how much? 28. So it's 28 into 28. Once we got the value of the sector and then the triangle, we can subtract them to get the area of the, was that area of this segment, one segment, right? So I'm going to replace the value here. This is how much? This is 1 by 6, right? So this is 1 over 6 into 3.14 into 28 into 28. From there, I'm going to subtract the area of the triangle. This is root 3 by 4 a square, 28 into 28. Now you can see that we can take 28 common. So 28 square, right? So it's 28 square is how much? 784. So I can write this as 784. And what you'll get here inside, if I reduce further, this is, no, yeah, this we can reduce, this is 1.57. So this comes out to be 1.57 over 3 minus root 3, whose value is not given. So we'll take 1.73 up to 2 decimal place over 4. That should give us the area of a design. Since we have 6 equal designs, so we'll multiply this with 6 to get. So let's say if I get the cost here, the total cost. As you know, the rate is given 0.0 35. So I can write the rate as 35 over 100 in rupees. And there are 6 designs, so I'll write 6 here. And that multiplied by the area of one sector, which is given as, which we have calculated as 784. And this is what the LCM we have to take here. So it's going to be what? 4 into 3, 12 is the LCM. And we'll be multiplying 4 with 1.57. 4 multiplied by 1.57 is 6.28. Now 4 multiplied by 1.57, right? Minus this is 3 multiplied by. So we'll multiply 3 with 1.73. So that comes out to be 51.9. Now what else we can reduce here? This is divisible by 5. So 5, 7 times and 5, 20 times. I can reduce this 6 as well. 6 1 times and 6 2 times. With 2, I can reduce this. That is, will reduce 3 times is 6, 9 times and 2 times. So what we are left with now, 7 multiplied by 392 over 20. And then we have to get this also. That is the difference of 6.28 minus. This is it's 5 point, right? Is 5.19, right? We'll get the difference. We'll get this as 1.09. Now for final calculation, what we are going to do is we'll multiply 1.09, right? We will multiply 1.09 with 7, that multiplied by 392, whatever it comes, and that divided by 20. So it's coming approximately, this comes as approximately 149.50. So we'll say that we have to find the A cost here, and we calculated the cost. The cost coming is this. In this question, that's an MCQ. We have to find the correct option. And it says area of a sector with angle P in degree is, of a circle with radius R. So if I write the formula here, area of a sector is what? This is theta over 360 into pi r square, right? So pi r square. Now it's saying that here the angle is how much? Theta is P here. So if I replace this with P, I should get this. Now I have to evaluate. Clearly there is no r square, so this is not correct. This is P over, rest is correct. That's pi r square, but here this is P over 180. There is no r square, so this is incorrect. Now check here, if I reduce this, what I am getting? 360. So I can say this is the correct option.